Welcome back, learners. So now to start with the first concept being the contact forces. So we need to know what are contact forces. So we do know that forces are placed into two main groups, being the contact forces and the field forces, which are sometimes referred to as the non-contact forces. So a contact force, it is the force that one object exerts on another when the two objects are in contact. So for us to have contact forces, we need to have two objects, and those two objects must exert a force onto each other, but they must be in contact with each other, hence the name contact forces. So we do have several different types of these forces, the contact forces. So you're going to be now looking at them now. The most important types are that we're talking about, the contact forces, are going to be looked at starting with the applied force. So the applied force, which is either a push or pull. Remember, when you are pushing something or when you are pulling something, you are applying a force. Hence, they are referred to as the applied force. So the symbol is F applied there, so with a footnote of applied. So these include any type of pushing or pulling on an object that causes a change in its position and speed. Remember, if the object is stationary and I come and I push it and also or sometimes pull it, what have I done now? I'm going to change the position of that object. That object was at this point, at point A, and I push it to a certain point, to point B, or I pull it to even a different point, to let's say point C. So it was at point A, I've changed now the position of it. And remember, this object was not moving. So if I apply a force onto it, it will start to move. So the speed is going to increase from 0 to a certain amount of speed if I either push it or pull it. And also, the contact forces, they also now refer to when we are stretching or compressing an object. So you can stretch an object or even compress an object, stretching it, making it longer and longer, like stretching a rubber band, and compressing it when you're compressing any certain object and making it smaller and smaller, squashing it. So those forces, they are referred to as the applied force. We also have the second one being the frictional force, which is denoted by, remember, the capital letter is the force and the small letter will be now the friction. So it's going to be the force of friction. Now this is also a contact force that opposes the movement of an object across a surface. The direction of this force is always parallel to the surface. So if we have a surface, and for us to have a frictional force, the surface must be a rough surface, as we can see on this picture here. There's a rough surface here, and if we apply a force onto the certain object, let's say this object has a mass of 3 kg. If we apply a force onto this object and this force is going to the right hand side, obviously the object will go to the right. However, there's always a force of friction, that is, as it says, that opposes the motion. So if the object is going to the right, then the friction is going to be acting to the left-hand side, opposing the motion of that particular object. Now, this is a contact force because it is between the surface and the object. Those two things are always going to be in contact with each other. And that frictional force is always acting parallel to the surface. If the surface was on an incline, we'll still have the frictional force acting parallel to the surface if the object was going up the incline. So the frictional force is always acting parallel to the surface, and it is always opposing the movement. If the object is going to the right, friction is going to the left. If object is going to the right, friction is going to the left. Now, the compression force, also another example of a contact force, that is often described as a force that squeezes something together. So the compression force, it is often described as a force that squeezes something together. So when two forces are acting on an object, acting in opposite direction, force A acting to the right and force B acting to the left, the object in between is going to be squeezed or squashed, and then that's going to be changing its shape. So an object, for an example, a spring or a balloon that is compressed between one's hands is subjected to a compression force. So when you have a spring and you apply a force in opposite direction onto that spring, we are saying that we are compressing the spring. The very same thing happens to a balloon. So a compressed object in turn exerts a compression force onto the head. Remember, force is always acting in pairs. When you are applying a force onto the object, that very same object applies the very same force onto you, but in an opposite direction. Then, another example of a contact force now, that's going to be the tension. So, when objects are connected by means of a rope, and the rope is pulled taut, and then the rope pulls on both sides. So basically, when we are looking at the tug of war, we have person A here and person B. And these two people are pulling on this rope. Now, this rope, there's going to be a tension force that is exerted onto this rope when person A pulls to the left-hand side and person B pulls to the right-hand side. There's going to be a force applied onto this rope, and that is going to be your tension force. So this force, as you've said, is called your tension force. We also have another type of force being the normal force, and remember it is denoted, so tension force is denoted by capital letter T, or you can also write force of tension with T as the footnote or with T as the subscript. Now with the normal force, N or Fn. N means normal, and this is going to be the force of a normal force. And then the force that a surface exerts on an object which is in contact and acts perpendicular to the surface. So we have two forces that are always exerted by the surface. We have the frictional force. Remember, frictional force is parallel to the surface. It acts parallel to the surface. And the normal force is acting perpendicular to the surface. So if your surface now, if we have a surface, there's friction that is going to be acting parallel to the surface, and the normal force is always going to be acting perpendicular to the surface. Perpendicular means there's going to be an angle of 90 degrees there. So the surface will exert if we have a surface and an object. This surface is going to exert a frictional force onto the object if the object is going either to the right or going to the left. Remember, if the object is going to the right, then the frictional force is going to be going to the left-hand side. It is always going to be opposing the motion. Now, that frictional force is exerted parallel to the surface. Now, the very same surface is going to exert a normal force, and that normal force is going to be perpendicular to the surface. That's either going to be upwards. However, should the surface be on an incline or be an incline, the friction will always act parallel to the surface, but the normal force, if your object is there, your normal force will always be acting perpendicular to the surface. Remember, there must always be an angle of 90 degrees between that particular force, being the normal force, and the surface. Now, with that said, we're just going to quickly go for a short break, and I will see you just after this.